So welcome everyone to the Ingredients for Math Class Are Everywhere with Matthew Aldridge. I know that you're going to be in for a great night with lots of activity and lots of conversation about math in everyday situations. It's always great to welcome people from all over Ontario to the OTF Connect session. And I'm just going to ask Matthew, I'm going to turn it over to Matthew, and if he'd like to introduce himself for you.
Yes, so hello everyone. I am a resource teacher of effective mathematics in the Peel District School Board. And this is my first time doing one of these webinars, and I'm very happy to do it. Tonight's topic is kind of my main thing, right? Getting teachers to see that math isn't just in textbooks or any book, but it's all around us. And I guess a more creative approach to tasks and the sort of things we give in our classroom. So that's what we're here for. And if you follow me on Twitter, or if you're part of the conversation on Twitter, you know that that's a lot of what I do. So you'll recognize some of the themes. Okay, and so as we look at the first slide.
Excuse me, Matthew, can you just speak a little closer into your microphone, because I'm having it's a little muffled.
Yeah, I'm going to just check the volume now.
That's better.
Oh, yes, I must have turned it down by accident.
Is that better for everyone else as well? Thanks, Maria.
Yeah, okay, thank you. And so I'll just say that part again. A lot of this conversation for a lot of us happens on Twitter. So if you're on there, you probably know that already and you can follow along. If not, you can still follow along. You don't need to be on there. So I'm directing you to my Twitter handle, @MatthewAldridge. And I posted in the chat room as well. And you can just see what we're up to. But tonight I posted a tweet. And if you do tweet, we can use #MakingMath. So the hashtag exists. It's been used for a few teacher math things, looks like in the US, but I'm just borrowing it for tonight. So if you're happy with something that you've created and you want more people to see it in your network or the world, feel free to tweet it. And if you tag my handle as well, I'll get the notification right away. But feel free to join the conversation. And if you want any help with that after this session in the days to come, just feel free to tweet me, because it's a very, very powerful thing. And I'll just put the hashtag, doesn't matter with the capitals, but #MakingMath. And I tweeted a couple times to that about today's session. So that's, I guess, with regards to, we're in the main platform, which is Blackboard Collaborate tonight. That's kind of the back channel. But in everyday life, that's my main channel. Okay, so I like to get started with a picture that inspired math, as I often do. And this one happens to be, I think it's a keynote slide from a presentation, and it has a screen capture in it, but also a Sketch, which is an app where you can draw and caption on the screen that I like to use. But so think anything where you can draw on the screen. So how does that work? Let me pull up my hand here. So we'll just start down here. So I put the question in, and I just put a little question below for critical thinking. Okay, but why did I do this? I did this because every time you turn on your iPad, if you have passcode enabled, you see this screen, right? So it's part of everyday life, and even my children. So from the time they were little, they'd take an iPhone or they'd find the iPad and they'd check they'd try and get in enough times, and then you'd be locked out, and it's really annoying, right? So I was thinking, how safe is that actually? And then I thought, would that be a good question to ask kids? And so I did, and it was some grade 7s at the time. And a couple of them knew the answer in like 3 seconds, but some of them really, really had to think about it. Does anyone in the chat space below, would you like to put a guess as to this probability? And I guess my clue is there's 4 digits. You have to put in 4 digits and think about how many choices you have each time. You might express that as each time I enter it, I have one chance out of, yeah, that's hard math. I may not remember that from school. So I'd say maybe if we were talking about probability, let's say grade 6, 7, and 8, maybe we'd talk about this. It's just an example of some math in the world. It is 10,000, yes. Yes, so 1 in 10,000. Yeah, and so you get locked out every time. And so just for anyone who doesn't know, it's 1 in 10,000 because there's 10 digits. And so I have to pick 1 of 10 things the first time, and then I have to pick 1 of 10 things the second time, and so on. So if you actually map that out with a giant tree, there'd be 1,000 things from 0, 0, 0, 0, right up to 9, 9, 9, 9. Yeah, tree diagrams. And so what's really neat about that is I was in Boston, Massachusetts, and I love to tell the story with this slide. I believe some of those American machines don't pop your bank card out right away, and so I must have forgotten it. So RBC called me on my cell phone within about 4 minutes because somebody tried to get in. So to my question below for kids, 1 in 10,000 doesn't seem safe, or does it? And that was my question below. Is my data safe? You know, and so what's interesting is the new iPhones or iPads make you use 6 digits, so clearly they might have decided it's not safe enough. Okay, so fun math, and you know, a lot of times we have probability in textbooks, and there's coin flips, and there's dice rolls, and all that stuff's great math, but this is an example that's in kids' world. And that's all you do is screen capture. So if you're on an iDevice, hold the power button and the home button. The definition of mathematics that I'm fond of these days is the extension of common sense by other means. And that's because I love this book by Jordan Ellenberg. And if I get a chance, I'll post the Amazon link in the chat room. But what's brilliant about it is there's not a single equation in the book. So he explains very, very big ideas in very readable language. And some of them actually are about probability, but some of them are about numbers and many other things. And he says, I just picked a piece of the quote. You're doing mathematics, the extension of common sense by other means. When are you going to use it? So I think in a lot of our school experiences, maybe it wasn't presented so much that way. Maybe more presented as something that happens in a book. And that's a little bit of a shame. Okay, I made a little note to ask you right now. So we use this STEM math is with kids. So if you want to take a few minutes to put in the chat room what you think math is. So we use this STEM, actually we used a hashtag, which I posted as well, just for a snappy way to get kids into it. But what do you think math is? So if Jordan Ellenberg says it's the extension of common sense by other means, what do you say? Don't be shy to offer an opinion. Math is patterns, there you go. And so another mathematician named Keith Devlin uses the science of patterns as one definition. Solving problems is a good definition for sure. And then I'm just going to, I've used math is making sense. Yeah, we hope so. Making sense of numbers. And we have a lot of things happening like number talks. Yeah, math is a mindset. I believe if all goes well, I will be interviewing Joe Bowler this week up in Brampton, and I can ask her about math mindsets. A very wise kid, I don't have the tweet handy, but she said math is number, space, and all kinds of measurable quantities. And I'm just going to type, I don't have the tweet handy, but a colleague from Burlington, his daughter said, math is numbers and annoyingness and hatred. And her name was Stella, and I always quote her on it because I believe there's far too many Stellas out there. And actually, I did a TED Talk in Chatham, Kent about almost 2 weeks ago now, and I used Stella's quotation. So I think there's a few too many Stellas out there who don't see it as common sense and who see it as numbers and annoyingness and hatred. Hopefully nobody in this room. Okay, nice definition. This one I wanted to point out. So I used this question, right? It's about drama club members. 3/4 were girls, then 2 more boys joined. Now it's 5 sevens. And it came from some old, I don't know if it was a textbook. I had it somewhere in a binder. And then it tells you the numbers between 20 and 40. And so this actually happens. So I thought I'd try this problem. It's about fractions. It's kind of okay. And some kid said, put them in a line and count them. That's how I would know. And that's not a mathematical response, but given the actual problem, what would happen if you were leading that drama club? You would count them. And so it's maybe an example of what Dan Meyer and others would call pseudocontext. So we can have real-world problems. And in our minds, we might say, okay, there's a drama club in the school. This is a good problem. But in reality, it's maybe not that interesting of a problem. And just for the last thing for this slide, sometimes we think, well, the real world's automatically better. But guess what? The mathematical world is quite interesting on its own. So certain things like playing with prime numbers, for example. A lot of kids really like doing number talks because they get to show all their different strategies and use mental math. And a lot of them find that rewarding. Okay, so it's just kind of pointing out that the real world is not always better. And actually, I've saved a bunch of really, really old problems. Like I had one about country and western LPs and cassettes. And so the context can fade away. We do need to be interesting. But I don't know. A kid said that. Put them in a line and count them because they didn't see the point of this problem. And we do want them to see the point. The inquiry slide, which is number 13, I kind of meant here that, you know, I guess we tend to turn things into buzzwords a little bit. So we have collaborative inquiry and then teacher inquiry and student inquiry. And bless them, but those are all ministry monographs. But what do we really mean, sort of in more general terms? Asking for information, investigating, posing good questions, so not just answering them. Engaging with math problems and tasks that are interesting, useful, or beautiful, which is kind of a good test if you're in the classroom. I'm giving this problem to kids. Is it useful in their life? That can be hard to say, but are they beautiful? Yeah, sometimes you can just see those solutions and they're just lovely and beautiful. But are they interesting? And I just think that's a really good test for the sort of math that we give. Just checking notes for this one. What do you think it means to inquire? So actually, this is a good point here. So what is inquiry math? I'm a word guy and a reader and a writer, so I'm trying to get, if I can get some stuff in the chat room, that's helpful for me. But what do you think inquiry math is, or what's a good way to inquire? Or perhaps if you're feeling questioning, why don't we do that more? You know, why do other subjects like science and social studies get to have all the cool inquiry? If there's any opinions on that, feel free to type them in. So we have math processes, the actions of doing math. And I think that just went down a little bit. Yeah, I'm finding the mic dropping down a little bit. It's literally, I'm watching it try and sneak back down. Is that strange? Like the bar on the microphone just keeps sliding. I have to watch it.
Yeah, I'm not sure. I don't usually have that challenge, but could be. If you could just watch it, or I'll let you know if we're having trouble hearing.
Okay, perfect. Not that, I don't even know. Strangeness. I'm just going to take it. other ways of thinking but getting the same answer. That's a good way to put it. When we think differently and we get to the same end. Investigating things. Very nice. Okay, just as I watch my mic bar here. But the next slide from my friend Tim. I was doing a lot of writing and thinking about what it means to be a back to basics math teacher or an inquiry math teacher. And I've been to Tim's classroom a few times, and he said, I think you're a 7.5, which seems like it would probably be about right. But I was just kind of more thinking it depends on the day and what I need to do. So if I was starting a new concept, yeah, I would want kids to explore it, always. But if I was right in the middle and we were just doing some practice questions, that might be different. Or if I was explaining something. And maybe I won't ask you to take your own opinion right now, but if you think maybe one being full basics, like old style math teaching, however you define that, and 10 being full inquiry, there's a good chance you're somewhere in the middle. And just think for yourself where that is. So I've worked with a bunch of high school math teachers lately, and sometimes we, like particularly middle school and high school, we have a hard time in giving that power over to the kids in the math class. Just sometimes we just do, like letting them talk, letting them explore the math. And so what would happen if we just gave it over a little bit more to the kids to let them make math? So you can think for yourself how you feel tonight even. And so to my beliefs, that I believe classrooms should be open spaces for thinking. Always. Always. And so, you know, why should language, arts, science, and social studies get to have all the thinking, right? Mathematical thinking, thinking critically in math class, just being open to it. And that's why I always use this picture of the kid's hand ready to write, because she's ready to show us her thinking. And that's so important. And so when we do problem solving, even with chart paper like this, or a lot of you have whiteboards, are we open to where the kids will go with it? Or do we have some kind of fixed endpoint in mind? And I think the worst case scenario is sometimes we have, you know, our own best strategy, and we're kind of going to pen kids in with it. That's kind of the worst case scenario. I think, and so often kids will surprise us with their thinking, and we should be open to that. And I built a whole TED talk on that math classrooms should be places of surprise and wonder. That link is not available yet, but it will be. But that was the big theme. Okay, and so we get to the main topic for tonight. So I'm now calling it, what could I do with that mentality of math planning? And we have this humble eggs. Can we try our whiteboard tool now? Can we, if I give you this picture, or you gave this picture to whatever grade you have, and I don't even care if it's K to 12. I think the high school kids would be able to do less with this picture. But let's say whatever grade you teach, what would a kid say? Or what is a question you would like to ask those kids tomorrow? If you open the eggs on the counter and there was just 5 eggs, regular egg carton, feel free to write anything on this page. Like just graffiti up all around it. That's a good thing. 512.
Okay, so the whiteboard tools, for those of you who aren't familiar, on the 4th button down is the text tool. So you can do either one of two things. You use the pen tool, which is above it, and write on the whiteboard, or you can take the text tool and type something on the whiteboard.
Perfect. So 5 12, 5 whole eggs. That's a good one. Connect to fractions. How many eggs do you see? And then, yeah, we can see that subitizing element with young children, like subitize the eggs. We see some fractions and some addition. Oh, very nice. Probability we have. I like this distinction between part to part and part whole. 5 whole eggs. You know, some recipes do call for part of the egg, like just the yolk or just the white. If anyone's feeling, if you're in the tweeting mood, and you can take a screen capture of this slide snippet, tweet it. Yeah, we have the equations with blanks, equivalence. 5 plus something is 12. And 12 containers, how many could we fill? That one actually reminds me a lot of Fosno kits, a lot of the Fosno type questions. More eggs to make 8. Yeah, it's fun to think of this picture going in, you know, over 10 different directions already. And you're definitely seeing that mentality. That the math is what you make of it. Okay, just as we finished that one, I recalled my recent Learn, Teach, Lead blog piece, and it was about the inquiry versus basics, but it was mostly about teachers like us taking a stance, so knowing ourselves and knowing how we need to teach. So that's the last link I posted, is a blog piece through the province. Okay, and so yeah, and so you could even come in the next day and like take one away and take one egg away and see what else happens. I don't know, you could leave a couple shells in and see what happens. But the point is, it's so common. It's found in everyone's house, and you can make math with that. Okay, we have some proportions coming through. That's probably going to be grade 6 to 8. From Jan, that's a good question. Nice. And so one idea that springs to mind that Mary and Small and others are quite fond of is unitizing. So if my unit's an egg, or if my unit's 4 eggs, or for some historical reason we have this unit called a dozen, which is 12. If my unit has 12 in it. And which is one thing we didn't mention, counting by 12s. If 12 is the unit, well, we alluded to that with packages. So don't overlook the comment. I've seen some wonderful work with Seesaw, where the teacher will just put it up on the screen, and it'll be right there in the classroom, but it'll also be out there for the parents to see. If you have a Seesaw or a class blog or something like that, I'm sure parents would love to send you these sorts of photos, especially primary. Okay, which brings us to, is Corianne asking where we get the phrase dozen from. Oh yeah, so why is that a unit? I know I was working with some grade 10 applied students, and they were learning inches and feet. There's 12 inches in a foot, but I'm not actually sure about the dozen, or the baker's dozen. The infamous double decimal, which exists somewhere near the Erin Mills Town Center in Mississauga. They still have it, actually. So at this time it was 1.18.6. And I took a picture because it's really weird. This one has more to do with sense making. And so the reason why we should use gas station signs as we explore place value is because it's the only place out there where they have not just tenths and hundredths, like cents, not just pennies and dollars, but they also have tenths of cents, which is the fourth digit. So all the way over to the south, the thousandth place. And it kind of pushes our thinking a little bit, and it's kind of fun to watch the numbers tick upward. And if you did the OTF session with Kyle Pierce, I know he has one with gas prices, but it forces us to engage that sense of place value. And it's so common in kids' world. This one's just bizarre. I use this one because, I mean, do they think we're dumb or something? So, but it's, do they think that we can't handle it? That we need this extra decimal here? Or that even makes sense? And we have a hard enough time teaching kids that, you know, the decimal doesn't move, right? There's only one, and it's right here. But when you added an extra one, well, in this case, it's just wrong. But you could ask kids, what does it mean? So then we have 18 cents and 6/10 of a cent. And what does that mean? And again, I don't actually know why the gas companies do that. They just do. So when I originally got that one, I said, oh, well, what could you do with that? Which is one of our big questions for tonight. Whoops. That's not good. Let me just go back and clean that up. That's an embarrassing yellow streak. What questions could you ask? Now this one, we have the internet too, so I think it actually is the London Eye. But if we want to use our whiteboard tool again, you might be thinking more upper grades now, upper elementary, but if you want to put on there what questions you could ask, I think we could probably come up with some cool things. So if you want to write on this screen with the tools, that would be good. Okay, I'll take the text tool myself. Okay. How many times to make one? Let's see, I can do this one maybe. What I'm going to do is I'm going to put some kid or person right here, which actually in its own right, how high would be good. Because if you had just a couple measurements, you could. Okay, I'm not good with that. It did not work out. How high anyway? Oh, degrees between the spokes. All right, connect to science structures. I think that'd be a fun connection. Why is it safe to go on? The wheel stops every 6 cars. How many times would you stop before you get off? Neat. How many people can ride the eye? So we could do some counting there too. Yeah, and the circumference is really interesting. How long would it take a full spin? Measure the angle. Oh, that's a perfect angle right there. Let me pick a different color here. Just perfect angle to explore here. Acute or reflex, and how many times around to make 1 kilometer. Angle, circumference, radius. So we could easily gear it towards the grade 8 curriculum. So circles being one of the new topics that year. So circles and pi. Which kids really, really like. Which they really, really do. Okay, and so the point is, if you just pick this question, you could do so much with it. And we just proved that in about 3 minutes. What's more, if you look at any grade 8, maybe 9 or 10 textbook now, there's oftentimes a question about a Ferris wheel. And, well, you know, it's, some of those textbooks were written before the internet, but they're, you know, they'll draw a picture of a Ferris wheel like publishers do, but really we have pictures like this everywhere in our world now, because it's the era of the ubiquitous image. This one I kind of like an example of a task. Oh, what does the decimal mean here? Because of course it's not $99.09. It's not $99.90. And then I was just sort of thinking, well, if you asked a kid, like, does that little missing bit matter, or is it really $1? You know, again, you could prove that by pumping the gas and seeing how closely matched they were. 99.9 cents per liter is quite interesting. Further, and I'm just going to point this out for this slide, you could do like a price per liter kind of inquiry. Like, how does gasoline compare to water? And how does that compare to milk? And how does that compare to orange juice? And we really, again, we don't need a textbook to do that. We can just find the pictures like this. Okay. So we could do something with that. This one, we were at the Royal Ontario Museum. I don't actually know. Maybe you can just think about this one, but it's supposedly $1 million coin. It would actually be a cool area problem because, I'll just draw one slice for you. I suppose we could model it with triangular slices. You know, I haven't thought about much about that one, but I just snapped the photo that says in the museum. What would kids say? What's $1 million worth? The next one came off of Twitter, actually. So some teachers were discussing as if the piece of paper is actually three-dimensional. An interesting conversation came out of that. But this is such a key point for me. It's not that we don't engage with complex ideas. I just think that sometimes we overcomplicate them. So finding interesting mathematics in simple things is often a really good idea, like this piece of paper. And of course it does have thickness. It does exist in 3 dimensions, but some kids would think it doesn't, which is interesting to talk and reason about. Again, I'll just mention, I'll just put the website into Kyle Pierce, Tapping the Team Mind. So I'm just reminded that he has a stacking paper 3-act task that he does, which has reams of paper. Nice. Yeah. That's great that kids want to know that. Because some will say no. And provoking thinking with pictures. This actually, 101cues.com. This is actually, I believe, it was the most popular picture for a very long time. There's a top 10. There's post a link in there. So if you don't know 101 Cues, it actually was and still is the launching point for Dan Meyer's 3-act tasks. He doesn't do as many. This one was the number 1 because there's a top 10 for a long time. And we did this one with a whole bunch of parents actually, and they had lots of really good ideas. From the surface area to the value of the pennies, to how many pennies, so the value in cents, the value in dollars. I just think it's a really quite interesting picture. Okay, next one. So if you can capture the moments like this and then turn them into math, I think that's really important. Because what's pictured actually happened. So he somehow knocked the center out of the toonie, and he actually really wanted to know the answer. So we decided to find out the answer. And so by one kid's estimate was maybe $1.71. I think because the silver ring is actually bigger in area than it looks. Okay, but I mean, this one could go further because I think it's two different metals. They're worth whatever they're worth. Okay, but based on area, they came to this answer. And so again, it was grade 8. But it's an example of where if you give kids the chance to think and to reason, they'll say, okay, exactly $1.71. And we want that. We want that certainty. We want that confidence. And we want that reasoning. It's so, so important. And then, so the main activity for tonight, I want you to have that confidence too. And I want that from all our teachers. But consult your photos. And I want to say here, I'm not on your device, computer or laptop. But most of us these days, there's various things. Okay, so if you're on an Android device or iDevice like iPad or iPhone, there's a camera roll. And you probably know how to get the pictures off there. Maybe you have iCloud on the internet. Maybe. Maybe you have Dropbox. Maybe. Maybe you just have the pictures folder because it's Windows. And so the link is now in the chat room. Thank you. And so if you follow the link to the Google Doc, I thought that paste a picture in and add a question that you might ask. Okay, so all you do when you're in the doc is you right-click and you put in a new slide. That's it. And I think when you leave tonight, you take this link, and if there's anything that you want to use in the classroom, you just take it. The first one I put in was from Costco, which I'm going to talk about. And an alternative is do that and or tweet the pic and a question. And if you do that, maybe tag OTFPD and use hashtag making math. So I'm going to go over to that Google Doc. And that's where we'll be for a while. And if someone wants to be brave enough, you know, I might just start adding a whole bunch of new slides here.
So Matthew, I'm just thinking out loud. So it seems that the connection's pretty good. So if you want to share your screen and show people where the Google Doc is, so share your screen, and we'll just give it a try. Have you got the Google Doc open right now on your computer? Okay, so go to that page, and then at the top, there's 3 boxes. If you the top left is a whiteboard. Go to the middle one, and we'll see if it works. Just so that we clarify. There we go. Okay.
Oh, well, that works.
So just if you don't scroll too quickly, I see lots of people joining the doc, which is great. Okay. So it seems people are in there. And how much time would you like? I can put some time. Do we want 15 minutes?
We should try about 15, I think. Yeah.
So they have 15 minutes to contribute to that and take a look at what's generated.
Yeah.
Okay. So we'll leave this up for now because it seems to be working.
Yeah, it seems to be working. Actually, I forgot to mention, if it was that you wanted to pick one from 101Qs or Estimation 180 or something like that, it can be from the internet too, right? I know all over Twitter yesterday and today was every kind of Halloween math you can imagine. So, and in the days leading up, pumpkins as well. So maybe you wanted to put one of those in. Yeah, did my tweeter? Oh, we have lots of tweeters. Now you can probably see this, but I'm going to actually retweet one here. Okay, I think that's it. Okay, back to our doc. One thing I would say is So you get a certain eye for it. So flip through the camera roll, and I get it. We maybe don't want to like private ones of our kids or our vacation, but sometimes there's math and things you've never even thought of before. But a really safe route is, if you don't want to share any of your own pictures, a really, really safe route is pick a cool one from 101Qs. Pick a cool one from, Estimation 180 was the other I mentioned. So something like that. We got some stuff coming. Okay, let's see any links I missed.
I'm also going to put a link up, Matthew, to a site called Photos for Class.
Oh, cool.
And they're all vetted through Creative Commons. So they're
perfect.
Copyright.
Yep, that's always helpful.
People can go into that site if they'd like to find something.
Yeah, that's a good idea. Have you got Mathematize as a new one to me, but that one's quite neat. Let's get estimation maybe. Put estimation 180 into the chat room. It's more geared towards reasonableness and estimation. Hey, there's a Ferris wheel right there. But he's got them numbered. There's 200, and there's 200 and 300 of them. The latest having to do with cereal. Can you read? Oh, basket. I love apples. Very cool. And just to the anonymous armadillo with the apples, I love anything that gets at estimation and reasonableness, so intuition and horse sense. So I spent a bunch of time thinking about OAME 2017, which is in Kingston, and hopefully a lot of people here will be going. But I decided I'd go estimation problems, Fermi problems, you know, because we want that. We want kids to get at estimation, reasonableness. Oh, and I like the sort of parallel sort of tasks with the apples as well. Yeah, what percent? Oh my goodness. Looks like a crazy fraction talk with cake. So percentage though we go. That one's pretty interesting. There's estimation 180 appeared. Very cool. Some pops about, oh, patterns. You can tell what they are. Oh, no way. One of those grocery store pop displays. I've often thought about using those. There's a Santa Claus pop display. Yeah, it's a good question. I almost want to know how many liters there are there as well. And how could we find that out? Oops, it's getting slow. Oh. Stay on here. Oh, kids sorting candy. We had that last night. They had the nice little stacks of Smarties, and I saw to the candy one. I saw a lot of interesting ones with concrete graphs. So I've done some work on grade 1 data management recently, and it just reminded me of that. Stack the different chocolate bars in rows, and you have a graph. Right, chocolates with chips candy. That's good. I posted one that I've always liked, which is Dan Meyer partial product. I enjoy how the 5/6 of a six-pack of juice disrupts kids' sense of that unit of 6. And it goes to some interesting places with unit rate, and I like that sort of question. Oh, tiling and transformations, one of my favorites. Yeah, the surface area of the plate and cheese balls. If it was just covered. Yeah, okay. And how would I even do that? And if I was a kid and I had the cheese balls, what would I do? I might make a row across the plate or something like that. So I guess I'm just, oh, the timer's on, yeah. So in 1 minute I'll just pick it back up, but that'll stay open and feel free to add to it. And definitely to take the link after tonight and try one. Okay. So yes, feel free to continue to add to that. Google Doc and slide collaboration is one of the most powerful things we can do these days. So yeah, so feel free to do that. Well, what do we have here? How many dandelions would be in a 3x3 square? Is it representative of the whole field? It's a beautiful field. The fewest and the most. So I think if you're looking at the dandelions, like what's a reasonable number? And so when I was with this grade 10 teacher today, and he kept asking the kids, is that reasonable? And I love that so much, because I think if there's one question we should be asking kids all day, it's that. Is that reasonable? And he was doing that. So if a kid says 1,000,000 dandelions, is that reasonable? But if they say it's in the thousands for the whole field, I think we can see that that would be reasonable. So that one's quite cool. And then I'm just drawing attention to this here, the fewest and the most. So in some of those tasks, like the Dan Meyer 3-acts and maybe the more estimation style, you want kids to come up with upper and lower bounds, right? So if it's the spherical cheese balls across the plate, you know, you can see 1 in the middle by itself. So you know that maybe 3 is ridiculous, it's too low. But then probably 3,000 is also ridiculous. So you want them to do those upper and lower bounds, and giving their sense of what's reasonable. Okay, thank you for that. Just carrying on a little bit in the second half. So part of this mentality, what could I do with that, is freshening up old things. So I took a photo of this old textbook, and it says, carry out calculations to find if the unit cost refers to the bottle or the tins. Okay, and if we're being honest, 750, we can't use that question with kids because 750 milliliter glass bottles don't exist, and 49 cents is obviously a long time ago. But that unit cost, okay, that's, how could we freshen this up? And then the most obvious glaring thing, we could have pictures. So we have flyers now. Every grocery store has a website. There's the Flip app. There is flyerland.ca. So kids could do their own inquiry into different types of drinks in different size containers and see how much they cost. So we don't need just this textbook question. We can freshen it up. This slide, the links are not live, but we can type them below, or you can just go through the presentation later. But we want kids to reason daily, and so we don't want problem solving to be an event, and we don't want reasoning to be an event. So there's 3 websites I've listed that they generally, they all started from the Twitter world, what's called the Math Twitter blogosphere. Visualpatterns.org. Her name is Fan Nguyen. That one's been around for years. There's literally hundreds of growing patterns. So couldn't you just pick a growing pattern every day and give it to kids? Oh, there we go. Perfect. We got our links. And you could give one every day. So it's not just in the pattern unit, but get them reasoning. Okay. Which one doesn't belong? Actually, the pictured one we used with high school teachers, but coincidentally my son used that same one in his grade 1 class here in PO. So it's versatile. So the 9, 16, 25, and 43, grade 1s don't know about square numbers and prime numbers, but they're starting to know about odds and evens, and they know about single digits and double digits, so there's something to reason for everyone. So the premise of which one doesn't belong, which was, it's a book by a guy named Christopher Danielson, goes by Triangle Man CD on Twitter, was turned into a website by Ottawa teacher Mary Bourassa, and people submit them. So there's graphs, numbers like this one, and shapes. If it should remind you of anything, it should remind you of Sesame Street. One of these things is not like the other. So in the purest form, you have to come up with a reason why each of the 4 doesn't belong. But I suppose a short version, you could just come up with one. A wonderful thing that you could do on a daily basis. And then fraction talks, Saskatchewan teacher named Nat Banting. Some of those are really amazing. I think I'm going to talk about fractions on the next slide. I am, so I should just go there. This is an example. This is my colleague Jennifer brought a bunch of flags to a session, and I just took a photograph of this one, and I believe it's Norway, but I can be corrected on that. But I wondered, well, so what fraction is blue, red, white, and then maybe if you gave them the outline on a piece of paper, how could they reason that out? There's a whole lot of interesting math and flags, actually. Okay, but my point on this one, something I want you to remember, don't ever let kids think that fractions are a strange new type of number. So sometimes kids think that, and we don't want them to think that, because they're not really. They're only as strange as we make them. And I just wrote paying attention to fractions monograph because it is the new research and the new work on fractions. And it's definitely worth a read, because what we're finding is, so some of the meanings of fractions we would overemphasize and some of them we would underemphasize. And I think sort of like, what's a good example? Well, the part to whole relationship, that's the sort of thing we always do with kids. But fractions can mean a whole lot of other different things, like an operator or a ratio, part-to-part relationship. And so we don't want kids to think fractions are strange, but there's a lot of new research out there. But we said flag provocations. So just as simple as that, go to the flags of the world, pick one, and play with the fractions. This slide I called app smashing. I didn't want to go too much into it, but you know, apps, if you're using apps, if you're on a computer, you know, you can do some of the same things. But this was an example of the flow. So I took, looks like 5 pictures, and then I put them into Sketch, and I think I wrote, actually I think I just did, I might have just done these boxes around them. And then in Pick Collage you can write stuff like this. So it's like, well, embedding multiple pictures with the task. And then I tweeted it, which you wouldn't have to do. But I think it's an example of where, well, a lot of our teachers are excellent at using Pick Collage and things like that to share with parents or to document kids learning. But I think I'm showing how if you wanted to compare all 5 of these different pop containers all at once, you can do it. But I just really wanted to emphasize, and it's the key point tonight, the camera roll is the starting point because everyone generally has one, and images are ubiquitous these days. Second example, it's still one of my favorites, and I'll actually show you what actually happened here. This here is actually a screen capture from Minecraft. So all they did was the kid just did these graphs, and they were comparing different quantities. So there's 3 sets of double bars. And then they went to EduCreations. And so the screen cap took it to the camera roll. They put it in EduCreations. And they didn't talk in EduCreations, but they just typed their thinking on the screen. And then I took a picture that they could have screen captured again. So I think it's a good example of how the game became an image with text. So I think it's a good example of using images for something new. Now if we can, I wanted to watch these same grade 6s in the CTV news clip. Do we have that?
Yes, we do. So I'm just going to, Matt, if you can just mute your mic so we won't hear it through your, we're just going to watch the video in a web tour. So for those of you who haven't done this before, I'm just going to put the link up, and I'll also put the link in the chat. If you can watch it in 2 ways. One of them, you can watch it with us, and just indicate in the using the green check mark when you're done. And if that doesn't work, I'll also put the link to the video in the chat box. So I just need to go and get that video. Here we go. For some reason, it's not playing in the media player, so if you can just click on the link in the chat, the Gaming for Good Grades link, and just come back to the room when you're done and put a green check mark in when you've finished watching. Thanks a lot.
Okay, thank you for that. I just wanted to say there that there was interest in the class, and they were grade 6s. They were interested in Minecraft, and that's why it happened. Some of them wanted to try it, but not all of them. So there's generally no one-size-fits-all app or tool. But I think the mentality of those kids in the video was what I wanted you to see the most. Sketching the math. This is an example from my friend Tim again. Pythagorean triangles. Actually, I used a couple like this in my TED Talk last week. But it's one of those things where anywhere that you can overlay a triangle, right-angled triangle, on top of a picture, you can have a Pythagorean theorem problem. And again, it's one of those things where those old textbooks are stale. It's always the ladder against the wall, okay, for one example. And in this one, we just have the guy standing a certain distance from the CN tower. So another example. And okay, grade 8 that year, we explored the hypotenuse of television. So again, if you were to just take that flyer or take a picture in Costco or Best Buy, you could have a math problem. And that's because they sell you your TV by the hypotenuse dimension, like a 50-inch TV. Made for some interesting math, interesting ratios. So when you plug in that 16:9 aspect ratio, and kids figured that out. And actually, there was a kid I just ran into, and this is almost 5 years later, and that's what he remembered from grade 8 math class. So I was proud of that. I gave him one thing for life. But they felt like it was dishonest because the hypotenuse or the 50-inch or the 42 or whatever is longer than how long the TV actually is. This one happened in class. We were exploring Pythagorean theorem again, and some kid said, and I quickly photographed and quickly wrote this: 3 identical squares can't form a right triangle. Why not? Well, you could argue they can't because of Pythagorean theorem. Or if they could, Pythagorean theorem wouldn't exist. But regardless, the picture shows quite clearly. So that's one more example. This one can come in about February every year, and stated contest odds are 1 in 6. So I've got 1, 2, 3, 4, 5, 6. Some kids will tell you that the next one should win. Reality doesn't quite look like that. You could explore a bunch of cups and see what happens. Another one that's in our world. Here's another Minecraft one. A guy named Brian Aspinall, who also does a lot for OTF, he has done a lot with Minecraft and patterns. So you just open a big open space, open world, drop in the pattern. So if my terms were 1 cube, 4 cubes, 9 cubes, you might see where it's going. But kids could build that. And here's another Minecraft example. But again, it's the screen capture and it's the creating the question. And you didn't have to write on the photograph. You could put the photo up, write on your whiteboard. You could write it anywhere. Okay, but it's the mentality. This one, we're going to attempt to watch one more video. And again, it's the kids and the mindset. But I used this question. We had the Ministry of Education in, and we did a project called Loving the Math, Living the Math. And so I actually got up. I knew we were going to do proportional reasoning, grades 6, 7, 8, because that monograph was brand new. And I got to 2 days before the project was starting, right? And I actually went to the movies on the Saturday night. And I've been just really thinking about what the task could be. And I saw this, and so that's why the photograph is not a great one, because I took it and I used it to kick off this project. But I just thought, well, what's a fair price? And so I had strong feelings about maybe the small cup's not fairly priced. And kids did a ton with that. They just did so much with that. The next slide illustrates all the different strategies from, I think, 2 of the different classes. But what was really striking is I had slightly different questions for grades 6, 7, and 8 based on this, and all the different ways, the slightly different ways the different grades approached it. It was very interesting. 8:47. I think what we'll do is, okay, that video is there if you want to start watching it. So Dan Meyer is in it, and some of my kids are in it. But I'm looking at the time, and I'm thinking I maybe finished a few slides, and then you can...
And we'll have the link to the video in the resources, so they can go back and watch
perfect.
that. Yeah.
Yeah, that might be better suited for later. I think that one's about 6 minutes, but it's such a huge project. There's so much video there. I just like that one. It's about the inquiry mindset. Okay, and so one other project we did, and this was some of our great instructional coaches and teachers in Peel. I called Costco the Temple of Unit Rate because it's actually fun to walk around there and make math, and so we took about 20, 25 teachers, and we did that. So that was our after-school PD. We walked around and we just decided what math we would do. We looked at proportional reasoning mostly, and we just took pictures and made math out of them. I think this one, the skid of Oreos, I had in mind how many cookies are there, how much are they worth, the whole skid, I think. Interesting about the Costco labels, the Costco labels all have just a really lot of math on them. They each have a unit rate on them. There's so much you can do. So one of my colleagues, Jillian Reed, so on that day, said big bars versus small bars, which is the better deal per gram of delicious chocolate. And that's the sort of thing you can do if you do Costco. And you could call it the Costco inquiry, yeah. You know, if you can't leave the classroom, you can just use some flyer comparison websites. But it's just interesting, and it's fun. So there's so much math embedded on these labels, and that's what I would show kids. So officially, proportional reasoning comes in at grade 4, but we know sort of that basis, like unitizing, the basis of multiplying, it's all just underneath in the primary grades. So you could do something with that. Now, if you look up this hashtag, Costco Math, I think you'll see a few photos there. This is actually one of my favorites of all time, if not my favorite of all time. And that's because I was very proud that the task is only 4 words. And we got really awesome work. And I won't ever forget. And I'm fond of saying that one kid said exactly 27 cents, excuse me. That kid went to a few different flyers because we actually had them in the classroom, did a bunch of comparison unit rates to come to that conclusion, and I was actually totally blown away. Further, this was during that Ministry of Education project, and I just walked down the hall, and I said, wait a minute, that's a terrible price, right? Nobody likes the baked chips, and the price was kind of crazy, 32 grams for $1.50. And this is where it gets interesting. If you think of those 2 bags for like $7 at Costco, it's probably like 5-10 times even more cheaper. And kids are interested in that. They want to use their sense to know when they're being ripped off. Anyway, it's one of my favorites. It's just a picture I took. Next time you see a vending machine, you should think about doing the same. So I'm getting to the end. I think if there's anything I want to go back over. Here would be a few minutes to watch that video if you wanted to, or we can just put any questions in the chat room, and we'll answer them immediately.
And I have a couple slides to finish up as well, Matthew, so that the timing works out really well. Yeah.
Oh yeah, so you usually. Okay, I'll answer questions in the chat room. We'll just make it that way, and I'll leave it on this side. I'm not expecting too much hate mail, but I'm just joking there. But anything else, I'm open to. Actually, even that. So mostly, well, I think I put Gmail there, Peel Mail, or the Twitter conversation. I wanted to hopefully inspire some new tweeters tonight. It would be a topic for another session, and it would be a good one. But Twitter changed my teaching career. And so by following interesting people and talking to interesting people, all of a sudden everything was different. And I'm actually really not exaggerating. So if you want to know more about that, just talk to me. You could tweet me some Costco math, tweet me some making math. Yeah, please do. So yeah, any questions, drop in.
Okay, just so Matthew's looking for questions, and thanks for a great session. Yeah, Costco is a fabulous resource for math. I'm always fascinated by looking at the signs and definitely to bring real life situations to the classroom. So thanks so much. Just a couple things.
Yeah, thank you.
The first one is the feedback form. As soon as you log out of the session, you'll be directed to a Google form, and that's a feedback form, and that serves really three purposes. I'm just going to stop recording.